Welcome to EDU World Space.
This is chapter 21, problem number 80. We have an electroscope. Assume that these two spheres are the leaves of an electroscope and their masses is 24 grams per each sphere. So we are asked to calculate the net charge that the electroscope must have had, which is basically Q, right? Because when we have Q charge on the electroscope, since it's conductive, Q over 2, they're sharing, each sphere is sharing the total amount of charge. So we're after Q here. In order to get there, let me draw the free body diagram on one sphere, okay? And then let me explain to you how we can get to answer what the Q is if we know the mass. So first things first, let's start. I'm going to do it on the sphere on the left. You can do it on the right. Doesn't really matter. It's just some of the directions of the forces are going to be flipped, but the method, it remains the same, right? So always there is gravitational force pointing down. There is string here, so there's going to be tension in the string with the angle, with this angle that is given. And there's going to be the electric force due to repulsion between these two charges, right? And then, since when we look at the tension, it's applied with an abrupt angle with respect to x and y, we're going to decompose this. So we need to find the y component and the x component of the tension. So if this angle is 26, then this angle is also 26. Let's call it theta now. So then what we have, this is the tension, right? The y component, this is theta, then is going to be t cosine theta. And the x component then is going to be t sine theta, theta being 26 degrees here. And then we said f sub g is acting on the sphere, and also f sub e is acting in the negative x direction. Now what we need to do is, you remember, we're going to write down the net force acting on the sphere in x and y directions. I started with the y, so we have t cosine theta, that is in the positive y direction, that's why I take it as positive, minus f sub g, because f sub g is pointing down, which is negative y direction. That's why I put that negative there. From the second law, there is no acceleration in the y direction, so m times y, which is m times ay equals 0, so therefore the right hand side is going to be equal to 0. From here, then t cosine theta equals f sub g. So the gravitational force equals to the cosine of the tension. And if we write down the sum of the forces in the x direction, then we have t sine theta minus Fe, the electric force, equals 0 for the same reason. Then from here, t sine theta is going to be equal to the electric force. So these two equations, they're important. Okay, let me write them down side by side. So t sine theta equals Fe, t cosine theta equals f sub g. So let's take the ratio of the left-hand side of these equations and the right-hand side of these equations simultaneously. These t's are going to cancel each other out. So I want to cancel them out because there's nothing asked regarding the tension, right? I want to get rid of it. You might isolate t out of the first equation and plug it in the second. It would do the same. But I find this method of taking the ratio to be more efficient and faster. So sine theta over cosine theta is tangent theta equals f sub e over f sub g. Remember, we're after q. And the term that has the information regarding q is fe. That's why I'm going to isolate that. So fe is going to be equal to f sub g tangent theta. F sub g is mg tangent theta, where, theta is 26 degrees. What is fe? The Coulomb force between the two charges. Each one of them has q over 2 the same sign. So that's going to be k q over 2 times q over 2 over the distance between the two. Let's call it d, okay? The distance between the two, d squared. From here, left-hand side is going to be k q squared over 4d squared, right? So the right-hand side is mg tangent theta. So now q squared then is going to be equal to 4d squared mg tangent theta over k So if we take the square root of both, then we have 2d square root of mg tangent theta over k, correct? So let's look at whether or not we can calculate q now. We know what m is, we know what g is, we know what theta is, we know what k is. However, we don't know what d is, so we have to find a way to calculate this d, going back to the case, the figure. So we define d to be this entire distance, right? Then the half of it, let's say this part, is d over 2, right? And we have this right triangle here. So let me copy it on a new page. We have a triangle. This portion is 78 centimeters. We know this is theta to 26, and we're looking for this side, d over 2, right? What is the definition of sine? Sine theta is going to be equal to opposite d over 2 over hypotenuse, right? In meters. Let's write it down. So from here, theta is sine 26, then times 0.78 meters is going to be d over 2, right? So if we multiply both sides by 2, then we have d to be 2 times sine 26 times 0.78 meters. And then from here, we're going to find it out to be 0.684 meters. Now we can go back to our final equation. Let me write it down. Q equals 2d square root of mg tangent theta over k, right? Now we can plug everything in here. It's going to be twice the 0.684 meters. Square root of m was 24 grams. Remember, we have to convert that to kilograms. Times 9.8 meters per second squared. Tangent 26 over k, being 9 times 10 to the power of 9 Newton meter squared per coulomb squared. All right. From here, Q is, well, I rolled it up apparently. So let me put it till there. Is going to be 4.9 times 10 to the power of negative 6 coulombs.